Just a second. 1 minute. So today is officially the last day, right? And then we have a study break Saturday and Sunday. So nice of the school to give you that time off to study for finals coming up next week. But right, that's fine. So we have not this page here. We're on our final exam schedule. I can't type schedule. I just want to search. Can't use my browser. I'm sorry. See if that works. There we go. So I was double checking to make sure we're on track. So we are Wednesday. Right? If you look up 1501, next one. Here we go. Wednesday, 11:30 to 2:30 here in this room or over Zoom. So the plan is I'll launch a Zoom session for anyone who has been attending remote. They can present that way. So I won't stream anything on Twitch. We'll just get together Wednesday. You can show off your blackjack project, run it, play a hand, show the simulation results, and we'll all say yay. So again, 5 minutes or so is the goal for presentations. Might have a question or two about your code. It'll be interesting. Everyone will approach it a little bit differently. Just part of the fun of programming. Like everyone can solve problems differently, and that's I think aside from learning like Python really likes colons and spaces or tabs or this sort of thing, what we've learned mostly I think is how to solve problems. How to take a problem, break it down to simple enough steps to make the computer, who's really dumb, solve it for us. And that's really what this is all about. So we'll have a chance to do that and then see how quickly we can lose money in blackjack. So it should be interesting, and we should be able to go from there. So why don't we fire up PyCharm? Before actually we start with that, I do want to show you, this is linear, a non-linear world. See if I can still get this article. I think we can. It's a Harvard Business Review article. And this is an interesting thought experiment here to start. So we're going to look at this and then see if we can illustrate a solution in a minute here with the plotting library. But just offhand here, if we're responsible for 2 fleets of vehicles, we have SUVs, they get 10 miles a gallon, and sedans, they get 20 miles a gallon. Imagine we have equal number of SUVs and sedans, and all the cars go 10,000 miles a year exactly. Just we're imagining here, right? It doesn't have to be perfect. We can replace one of our fleets, either the SUVs or the sedans, with more fuel-efficient vehicles. We can go in our SUVs to get from 10 to 20 miles per gallon, or we could take our sedans and go from 20 to 50 miles per gallon. Which one is better? Don't read that last paragraph. I went too far. Which one's better? Right, in terms of fuel savings. I can't scroll. Here we go. So we got a vote for B. Appreciate your confidence voting. Anyone else have a vote? A or B? A. Oh. Are you just voting A because he voted B? Or
I'm voting A because I feel like it's a trick question. I didn't
okay. So you have just, and I'm not trying to make fun of it at all, but like you haven't really thought through or done the math here. You're just intuition. Yeah. We'll say, okay, that's fair. That's okay. That's what this is about. This is about how we think about things, and we tend to think very linearly. That's a hard word to say, and the world is not very linear. Turns out. Does anyone else have a vote? A or B? Which will give us a better fuel savings? You can guess. It's okay. All right. I guess that's enough awkward silence. So, turns out the answer is A. Yeah, the answer is A. And we can look at those values here on our own. So let's start up a new project here. So this is plotting and graphics. We'll do both today. Again, sorry to have missed you Monday. The little guy's doing a lot better now, thankfully, though. Come on. Close that. So to look at this here, right, we essentially have our SUVs. This is miles per gallon, right, is 10. And we have our sedan, miles per gallon is 20. Right, this is our current. And this is what we currently get. So if each vehicle drives 10,000 miles, this is miles driven per year, is 10,000. Nope, zeros, not parentheses. Right, we can calculate the fuel used by each vehicle. Right, that's a pretty quick formula for us. So this is SUV gallons per year is going to be my miles driven per year divided by the miles per gallon. Right, if I divide out the miles, I'm left with my gallons. That sound right? And then I'll have my sedan gallons per year is my miles driven per year divided by the sedan miles per gallon. And we can print those if we wanted, right? So print our SUV miles per year and print our sedan. And again, probably make these a little prettier here, right? We can make it a formatted string and say, SUVs use gallons per year currently. Sure. Right? And we can do the same with our, single quote there. There we go. Same with our sedans. Sedans use our sedans miles per gallon. So we can see right off the bat, our SUVs use 1,000 gallons per year. That's a lot of gas, right? Just to go 10,000 miles. Like, that's I think an average driving on like 1,000 miles a month seems to be somewhere around, I don't know. What is average miles driven per month in the US? Okay. Yeah, so more than 10,000 in a year then, right? If we're at 1,200 as our average, 12 times 12, what does that put us at? 144,000? Is that right? So that's like 40% more than this 10,000 estimate. But again, that's okay. Some of those are personal miles, right? These aren't all work miles. So maybe this is just your fleet work miles. So each SUV uses 1,000 gallons per year, and each sedan uses 500 gallons per year. What we want to do then is see, well, what's the future value here, right? So then how about we look at new SUV miles per gallon? Well, that one's easy. We know it's 20, right? And the new sedan, that's 50. So we know we're going to go from 1,000 to 500 with the SUVs, right? Because we know what the sedans get currently at 20 miles a gallon, right? So right off the bat, we should probably have in our head, okay, so we're saving 500 gallons of fuel per vehicle in this fleet here by going from 10 to 20 miles per gallon, right? I don't want to make any jumps here, and I've talked about this problem a lot, but this one fair? So to go from 20 to 50, though, how much are we going to save? Well, we have to find out, right? So let's get our new SUV and our new sedan. So same miles per year, but now divided by the new variables here. And again, we'll print them out. This is new SUVs and new sedans. Anyone doing that math in their head already? 100,000 divided by 50? Or no, sorry, 10,000 divided by 50? Well, you go from 500 to 200. So our net savings here then, right? So we can print that out, right? Because that's pretty nice here. So net savings in fuel used per year in old versus new SUVs. That's an ugly sentence there, but does that make sense? Be my new minus the SUV gallons per year, right? And then that should be the other way around, actually, right? We should take the bigger number minus the smaller number, right? So then our sedans miles per year, gallons per year, minus the new sedan gallons per year, right? Just do some quick arithmetic. New sedans. There we go. So we're saving 500 gallons a year per SUV or 300 gallons a year per sedan to go from 20 to 50. So more than doubling your efficiency, you have diminishing gains here, right? Let's take a look at our article here. Turns out it is not this linear picture as you might think. Hey, as our miles per gallon increases, our fuel goes down. That doesn't go down linearly. Man, can't say that word. Right? It goes down more like this. Right? You get dramatic savings near the front part of the curve here in fuel, and very diminishing savings as you go further and further and further. So to go from 50 to 100 miles a gallon, right? How much do you think we're going to save? Say we come up with a sedan that gets 100 miles a gallon. Should we do that for fun? Why not? So we'll call this because this doesn't exist yet, right? I guess maybe some hybrids might be able to claim that, but I don't know if they're actually getting, we'll call this future sedan. Just see if it gets 1,000, right? Or 100 miles a gallon. We'll see what we get. The future sedan. Okay, then our future sedans. So we could get to 100 miles a gallon. I'm sorry, use 100 gallons instead of 200 gallons to go from 50 to 100. You're not saving that much fuel. So even with our sedans currently at 20 miles a gallon, if we went from 20 miles a gallon to 100 miles a gallon, we're still saving less fuel per sedan than an SUV going from 10 to 20. Right? It's one of those curves. Is that logarithmic? I think that's a log curve, essentially, right? Maybe not like a basic one, but something in there, right? It goes real steep real fast and then peters out pretty quick. So the amount that you're saving diminishes as you increase your fuel efficiency. Just kind of depressing to think about. Like all of our federal pushes to increase fuel efficiency is good, but like to go from 30 to 35 doesn't really do a whole lot. But to go from like 10 to 20 was huge. That was a huge savings in gas nationally to have that sort of level. But when we fight over from 25 to 27 to 30, like, is that is the right response there? I think it's not nothing, but it's not as significant. So now this is all well and good, but people like pictures, right? We're very picture people, right? So what we want to do is we want to use our plotting library. The plotting library is fantastic. Now to do this, we have to install the library. It doesn't come with Python, and that's okay. So we can go and add it. So in PyCharm, we're going to go to our settings. Where did I find it? So file and settings here. If you're in Mac land, it's in a different menu, which irritates me because Macs are stupid. But so we want to go to our project interpreter. So this is our project interpreter. So this is the Python version my program's using. And I want to add a package. So we get a couple packages with Python already. Pip is the really cool tool that Python uses to install packages. You can do everything from the command line with pip. We don't really care right now. We can get to that later. And we will do some command line stuff next semester if you continue on. But for now, we get a little plus button here. I said, what package do you want? Here's a bunch of packages we could go find for Python. I don't know what most of these do, but if you go look up matplotlib, this is the Python plotting package, matplotlib.org. This one is phenomenal. So we want matplotlib. We want to install that package. So it will download and install this package for us for plotting for my project. So again, if you're using virtual environments where your project has essentially a copy of Python, we're installing this to that virtual environment. Now, this is where virtual environments really shine. Now, matplotlib is pretty fine, pretty stable. You're not really going to break a whole lot of stuff. But if you are using your operating system's install of Python, right, like program files, Python, whatever, and you install a package, it now is available for all Python on your system, which might not be what you want. So again, matplotlib, I will go out on a limb and say is pretty safe. I don't think that's much of a stretch. And notice it installed a bunch of other stuff too that it depended on, which is really cool. Like it's a one-click and does a whole bunch of cool things. It's a kiwi solver. I don't know what that is. I do like kiwi. Kiwi is an underrated fruit for sure. Okay, so we have the matplotlib library installed now, so we can go and use it or import it if we want. To go and do that, the common thing, and I can never remember here, so I'm just going to go copy it. Wow, there we go. We'll just copy off our iBooks here. Not right now. No, thank you. We want to import. Now, specifically, we want the matplotlib module pyplot file. Right. So inside the matplotlib module, which is just a folder, right? Modules are folders. There's another one called pyplot. We want to name that plot, plt, plt. I don't know why. Everyone does this. This is just what everyone does now. You could name it Apple, and everything would be apple dot. Doesn't matter. But so we get plt. And then what we get to do is we get two quick functions here. We get a plot function and then a show function, which is nice. So plot takes two attributes, or I'm sorry, generally two lists, two collections. You want the x-axis and you want the y-axis, right? And then it will go and plot them for us in a basic line plot here. So the years plot, right, is just a quick range, 1850 to 2012, and the temps plot they pulled out of a file here, which is fun. Like we can combine. Now I can read data out of a file. I don't want to type a bunch of stuff in, but we can do that. So I don't have a list here, right? Not something I have. So we could build a list though, right? So let's ignore all the stuff we did before, and let's see how do we graph these, right? How would we show this as a list? So I want, this is my miles per gallon. How about a range then? Is going to be range from, we can go, how about 10 to, let's go to 100, right? So we'll go 101. So I'll get from 10 to 100 because it doesn't end at this last value when I range. So I'm going to go for all possible miles per gallon, all integers, right, of 10 miles per gallon, 11 miles a gallon, 12 miles a gallon, 13 miles a gallon, 14 miles a gallon, on and on and on and on and on, right? We'll do that. And then we'll look at, this will be now my gallons used is going to be a list here. Now we could do the fancy list comprehension. I forget how to do them half the time. We could, so I think we'll just do it the slow way, and then we can come back and edit it in if you want. So we can say for, this will be my MPG, essentially, right, in my miles per gallon range. And I think we're okay leaving this not as a list type. I think we can leave it as a range. Remember, it's not actually a list, but we can still iterate over it. We're not going to change anything inside of it. We should be okay. We'll take our gallons used then. Is going to, we want to append the miles driven per year divided by my miles per gallon, my MPG value. We'll just append it in. So it'll be 100,000 divided by 10, append. 100,000, I'm sorry, 10,000 divided by 10, 10,000 divided by 11, 10,000 divided by 12, 10,000 divided by 13, on and on and on, right? So we should get our 90 values in here. And then we'll have an X and we'll have a Y, right? So our X can be the miles per gallon and the Y can be how many gallons I use. So we should be able to call plt.plot, and I'm going to give it, so my x-axis first, right? Which one do I want to give first? It'll be my miles per gallon range, and the y-axis will be my gallons used. And then I want to show it, plot.show. Right? Let's give that a try. Here we go. Here is that curve. So you can tweak all of these labels and axes and add other descriptions. There's like a gazillion things you can do with matplotlib. We're not going to look at the gazillion things. If you want to see all of them, you go to matplotlib.org and you go nuts here. This examples page is just amazing. Like anything you want to do, it'll give you examples on how to do it. It's really cool. Super cool. So like our basic plots here, right? You can do all sorts of things, which is fun. And you can even run them in Jupyter notebooks and all sorts of other fun things that we haven't got to yet. They also have their reference here is amazing. I think I want, is it, oh goodness, is the API reference? No, I don't think that's it. My goodness, they changed their, is it the example gallery? There's even more examples in the gallery here, which is amazing. I don't even know what most of these are. What's a tri-contour smooth user graph? Tri-interp demo? I don't know. Trip color demo? But you can do all sorts of fun things. You can do multiple plots in a single plot, right? Lots of cool things. I'll find the right page for you later, but this essentially is our quick graph. So this is gallons used, right? Now, what we want to show, though, is gallons saved, right? So we can add another plot onto the same thing here. So let's, while we're doing this here, we'll have a gallons saved. Gallons saved, right? There's going to be a list. And as we're calculating this, excuse me, we'll take, so we know the starting SUV was SUV gallons per year, right? So we're going to take that and we're going to subtract whatever we get back from this calculation. And again, we know order of operations will work, but I'm a big fan of putting in parentheses to be explicit about that. And we'll take that and append it. We'll calculate how many gallons we're saving each year at this new fuel efficiency. Right? So we can also show, so it's the same axis here for the X. We're going to show gallons saved. So we want to, what do I want? A lib label plots. It's not X label. Where is it here? Is the one? I want to name my plot. There's so many things we can do. It always upsets me. Change the markers. want to name it here. Don't want subplots. I don't want access labels. Just regular labels? Ah, no, that's the title. Position the title. That's not what we want. Label. Multiple plots. This one it? Set title. I don't think that's what we want. No, it's not what we want. Oh, goodness. There, this is the one we want. This one. Oh, label. Yeah, okay, there it is. So when I go plot it here, I'm going to say, hey, I want the label to be, this is my gallons used. And then this one, the label will be gallons saved. Okay, and this should work to show it because they both have the same x-axis. Our plot should be happy. Oh, where's my label? It didn't show it. How do I get the key here? Oh, the legend. That's right, we have to show the legend. Plot legend. Look, everything uses PLT. I don't know why. All your examples you find online are going to use PLT. Come on. There's our legend. Okay. And this is pretty basic, right? It's just inverted. And I think that one makes sense for what we're getting here, right? For the amount that we're saving. So this is our basic plots. These are just line plots. But how cool, we can just throw in an x-axis, throw in the y values, and we're good to go. It shows us the things that we want. It's a really cool library, which is neat. Now, I think I mentioned we're going to briefly talk about not lying with our data, because it's really easy when you're presenting data to lie and to tell a particular story that you're looking to tell. And sometimes it's hard to avoid, I'll be honest, because we want to show a particular thing and like, I want to show you how cool this is, so we design our graph to show how cool this looks. Most of the time you do it by manipulating one of the axes, right? And you don't show most of the data here. There's a very common one that presidents like to use when they show GDP sort of growth or trends, and like they'll squish down this axis to make their year look like it's a huge change when it's like a 1% change. You're like, this is stupid. Like, we know how to read a graph. It's not 10 times as good. You just have shrank the axis a lot. There's a pretty common say, was it How to Lie with Data? I think it's the name of the book, right? Lie with data? No, that's bad data. Data Science Central. Oh my goodness, why so many pop-ups? Holy cow. That was a lot of pop-ups. Yeah, okay, that's, there's one like specifically with graphs. Data visualization, does this fit? Yeah, I think Huffington Post here. This different y-axes here. Yeah, I think this is, wow. I need an ad blocker or something. This is awful. So exact same data here, looking at interest rates. If this is your y-axis of 3.1 to 3.15 versus 0 to 3.5, exact same data, just presented differently. So if you want to tell a story about interest rates increasing quickly when they've increased by like 1/100%, you present it this way. Right? If you want to show them being relatively stable, you present it this way. Pretty easy to do that. This is an actual screenshot from Fox. Tax rates. If the tax cuts expire, look how much bigger this graph is. It's 4.6% difference. There's no zero axis here. We go from 34 to 42 to make this bar look much bigger. I would argue this is misrepresenting your data. A lie might be a bit of a stretch, but misrepresenting to tell a story is essentially lying or misleading someone. Is that fair to say? Knuckleball velocity. Look how much slower that got. It's like 2 miles an hour different. It's not half the speed. These sort of things are ridiculous. Your cumulative annual revenue. This is a very interesting story here when you show cumulative annual revenue. But this is annual revenue, not cumulative. So if you want to go present something to your investors and have them give you a big bonus because look how much money the company's making, you show them this graph. If you want them to see how much less money you're making per year now that you're the CEO, you show them this graph. Obviously, CEOs don't want to present this, right? Because they want to get their big fat bonuses, right? Conventions. This is not a pie chart. 63%, 60%, and 70% does not make a pie chart. You have one pie, you have 100%, right? I don't even know how this makes it. I'm sorry? So someone must have had, I don't know who came up with this graph or what they were trying to show. Like, hey, it's evenly split, but no, I don't even know. Gun deaths in Florida. Notice anything interesting about the y-axis here? This is 0. They're like, hey, look at the gun deaths decreasing since we passed this law. No, that's an increase because you flipped the axis. Like, as someone who works with data, I find this particularly offensive. So please use data and graphs responsibly. Okay, we can keep looking at fun examples, but I think that's it for this site. Were these as painful for you to see? Okay, good. It's not just me. I'm not crazy. So all sorts of crazy things we can do with that here. So we should add in some labels, right? Let's add in our X and Y labels because that'll be prettier here on our plot. So our X label then is, this is miles, not miles per gallon. And this one, we don't really have a good Y label because we're using 2 different values here. So I think we can skip the Y label, right? And just have our X label. I think it's going to run. Did I hit run? Stop. Oh, it was running. I was impatient. There it goes. So we'll just have miles per gallon because this is our label essentially for the Y. We don't have a single Y label, right? Is that fair? Okay. That fun? All right. Have I beat it to death now? Is it no longer fun? It's okay. All right. So matplotlib, check it out. Anything you want to graph, basically, you can go graph here. Just find their examples. It's really neat. Bar charts, yeah, I'm like, just the amount of stuff you can do here blows my mind. Oh, histograms. There we go. Demo of the histogram function's different hist type settings. You can have like, they're so pretty. They're so neat. Multiple histograms side by side. Okay, anyway. So check it out. All sorts of fun things here. The book gives you a couple examples of some plots you can go do here. Right, this is ocean temperatures and pirates. I don't know. Where's the other funny site? Funny correlations. This is a good one here. There's a whole. Is this it? Spurious correlations. U.S. spending on space, science, and technology, and suicides have an interesting correlation. Number of people who drowned by falling into a pool in films Nicolas Cage appeared in. Correlation. Per capita cheese consumption and number of people who die by becoming tangled in their bed sheets. again, I think it's obvious to all of you folks, because you're well-educated people, that correlation does not mean causation, right? Just because data is correlated doesn't mean one causes the other. Divorce rate in Maine, per capita consumption of margarine. This is multiple pounds of margarine. In 2000, they were up to 8.2 pounds of margarine per capita. How much margarine are you putting on your toast?
Watch, we have to get divorced.
Okay, so boxed mac and cheese wants like half a stick of butter or margarine per box. So if you eat a box of mac and cheese every day for lunch, because normal people do that, right? That's not just me.
Because I feel like it's too much butter.
They've decreased it over time, but I use the old recipe because it tastes better, which has more butter. And it's for my kids. My kids need the fat. I don't need it, and I don't eat the mac and cheese anymore, which is sad because dairy or lactose makes my body upset, which is really sad. Getting old is rough. But 8 pounds of margarine. Wow. Age of Miss America and murders by steam, hot vapor, and hot objects? Okay. Total revenue generated by arcades and computer science doctorates awarded in the United States. This might be my favorite one now. It's only 1,500? Wow. Oh, this is older data. I feel like we've got to be going way up by now. But interesting. A fun fact: the guy is no longer here, but one of the founders of this department, his PhD was not in computer science because it didn't exist back when he got his PhD. His PhD was in applied mathematics. He's one of the coolest guys I knew. Our lab is named after him now, the Ellen Mogan Lab. Super cool. Worldwide non-commercial space launches and U.S. or sociology doctorates awarded in the U.S. Per capita consumption of mozzarella cheese. We're at 11 pounds of mozzarella cheese per capita. I used to. Pizza's good. They make non-dairy cheese, which is halfway decent. Not too bad. People who drowned after falling out of a fishing boat, the marriage rate in Kentucky. Okay. Anyway, this is you can spend all day here, being entertained by these spurious correlations. We were going to do some graphing here for lab. Apologize, I missed you for lab. Hopefully, it was a good chance to work on your project. So if you wanted to, and don't feel like you have to at all, but you could graph your win-loss results across your starting hand values or something, and be able to more easily see which is the better winning percentage. Don't feel like you have to though, but that's something relatively easy. Once we have the data in this tabular format, if I want to graph, hey, what's my win percentage if I hit or stand or whatever we want to look at, we should be able to see that pretty easily. So that's one of the powerful things about graphing is you can pick out those high points pretty easily. We could just do a max function too, but like you could see, more often you win here, less often you win with these values, and just helps us see some of that stuff, which is nice. Yeah, it's all fine. You can check out the rest of these things at your leisure. And then for graphics, the other super cool thing we can do with graphics, we're going to look at another library called tkinter. No idea why it's named tkinter, but it is. So we're going to go to our settings. We want to add a package here for tkinter. And where's my main tkinter? Oh my goodness. Did I lose it? Tkinter. Tkinter. There. I just want the main one. I think my search is no good. Oh my goodness. There's too many in here now. Wow. That's not what I wanted. No? Tkinter. Tkinter. Do we not Need this? Maybe we don't have to go download this one. I might be remembering wrong. It's been a year since we did this one last, right? So we can just import it. tkinter. Oh, okay, nice. As call it TK, I think. TK. TK. There we go. Now this gets to be interesting here. We'll just steal their whole example here because why not? Right? We can do that. Oh, maybe I'll add a new file in here. It's graphics. Bless you. Let's go import that here in our graphics file. So it takes advantage of inheritance. So we make an application that is a tkinter frame. Frame is like a window we can see. And then in the init method, we init our superclass, right? Let frame do all the things it needs to do with its init, like we do with inheritance. We set up a master frame if we want. We can set titles. We can set it all up. And then we want to give it a length and width, set the application, and start it running here. So this should, if we just run graphics here, we get an empty frame. Not super exciting, but now it's a box that I can drag around, I can resize, right? It's a window like we're familiar with using, which is really cool. Then what we start doing is I can start putting things inside of it. So I can add items and start using this canvas to put things on the canvas, which is really cool. Let's go grab all this here. We'll just steal their example again. And we can build our own bar charts. I don't recommend you do your own bar charts because we have a nice library to do that for you, but just showing you some of the things you can do with this canvas, you can just draw on it. You can make shapes on it, which is fun. So if we wanted to make our own like tic-tac-toe game, essentially, we could draw on some lines, and then when people click on things, put in our X's and put in our O's, which is much more interesting than when we did tic-tac-toe in the command line. Like, hey, which row and which column do you want? People don't want to play like that. They want to click a button, right? Let's see. So those are all those ones. We don't want the color chart, and we don't even want to do it by hand. So we want like tkinter add a button. How to create a button. So we've got the canvas. We're going to make a button. There we go, and we'll place the button. Sure, why not? Let's take this whole one here. Why not? I'm even going to cite a source here because we should do that. Wow, that's an ugly URL. Sure. They add in like all this other stuff after there, but that's fine. Right, we get a button. So it has some text, the button I can click. When I run it, it ends the program. Just kills it. Which is probably not what we want it to do, right? We actually want our button to do something interesting, right? Add button action. So we can tell it we want to run a function. Like, hey, the command is hello, it will run the hello function. Sure, so we can go write a function here. So instead of destroy, we want it to be, we'll say hello. And we'll go write a hello function. Fine, hello. Now, when we run hello, right, we could do the message box. That's not the most interesting, but we could pop up. Let's do this one. Command is hello. It's still showing info. Let's do button action. To do something on the canvas here. Let's see if this one does it for us. Is this the same one we were doing before? Yeah, that one destroys it. That's not the one we want. Hit a button. Command quit. We don't want the quit button. On a better button. Print. No, that's only going to print something. We don't want that. button. I just gotta find the right one here. Ah, here we go. So this is our custom button. Is that it for us? Find button to click. That's not what we want. I think this is what we want. Self-draw. Draw it here. Okay. So we need where we have our attributes here. I'll draw. There we go. A game of life. Here we go. How fun is that? Yeah, we don't want to do any of the time stuff either. But so if we're using our class here where we have self, right, then we can go and update that individually with these functions here where we just create the canvas, right? Our function is going to have a little bit harder of a time to do something here. Oh, we'll just print hello. This ought to work for us, but see, it's printing hello to the console. It's not changing anything in the canvas because I don't have access to the canvas. This function here, just called hello, has no idea what any of these values are. So we want to put all of that inside of a class like we had. Where's our other example we can steal? Here we go, like this one here. So if all this is inside of a class for us here, then we'll go and add that button. So we can get rid of the rectangles here. And I want to add that button. So our button here, we'll add the button, place the button. Self.button is a button. And then we're going to place it. Self.button, place it. I think that'll work for us. Let's see if that goes. And then we can add in a method here then inside of our class, define a hello method. That should be able to take our self canvas and do something with it. So on self.canvas, right? There we go. Self.canvas. Then I'd like pack. Self.canvas. Draw a rectangle. Let's see if we can draw one of these rectangles. I'll create rectangle. What's it not like here? Does it match indentation level? I think it does. Did we mess that one up? Let's see. This was what runs for us. Nope. Fine. Hello. Oh my goodness, it's off by one space there. Our init is off. There we go. Super off? Okay, maybe that'll run now. Nope, button is not defined. Not a button. What is it here then? Button. Oh, TK. That button. There we go. Let's try that. The imports were a little bit different here. Let's see if we can. Nope. Root is not defined. We're getting close. Let's see. Root line 13. K.root. Okay. Let's see now. Attribute root? Really? Where did root come from? Enter. or not have root. Where are we getting? Oh, root is TK. Okay. What do we want? I think we want that to be self. Might be self master. You can try it and see. Nope. Hello is not defined. Oh, how do we get it to use our other function? Let's see. TK button use class function. We just have to Google the right things here. Class to call a function. Button second dot. It's not the one we want. In the button class. That's the same question. Button. Where's its command? Command. Oh, self dot. Try that. There. All of that just to get it to run a method. But again, doing it over and over and over is not going to do anything because it's drawing the same rectangle. But we can make our buttons, like put our buttons in certain locations, make the buttons clickable. So if we add in 9 buttons or any sort of option we wanted to do, right? We've got choices on how we want to deal with it here. But again, if we create it as a class where I can access these attributes here inside of my functions, we can go and add in anything we want here. We can make these be random too. Might be fun. Like let's just draw random colors. Right? We could draw a bunch of random colors as we went. So let's make this bigger. Let's do like 800 by 600. And then let's make this button's a little large there. So how do we make that a little smaller? But like, let's do 5 by 5 color. And we'll do draw a circle. We'll rename this thing here. Draw a circle. And I think we can create, here we go, create an oval here. And let's take a look at tkinter create oval. So you give it the x0, y0, x1, y1 for where it's going to put that circle. So it's a random values here, right? So we need x1 random.randint. Let's just pick, I don't know, from 0 to, so the x's are going to be 800, right? And the y's will be 600. To int go to 800, and then a y1, we can go to 600. And a y2. We got to import random, don't we? Import random. And we'll use x1, y1, x2, y2. Now it'd be fun to like pick random colors too, but we can get to that later here. So you can draw some random circles. Whee! Random circles. So again, we have all sorts of fun things we can do now that we have a program that's clickable, right, which is much nicer to work with, right? Let's do one more example. So tkinter text box. So we want a, come on, text box. Title, text. Oh, no, I can type it. What's the size? I don't want a scroll bar. Get text from text box. See if this one's in. Input text. Text frame. Yeah, let's try it. Try this as another example. Oh, here's our little copy button. Let's do another one here. Nope, a new Python file. Text input. I type something in, and it prints out. Super interesting. But once I can start typing things here, I can ask the user to enter values here and click a button to get some result rather than type, hit enter. We can give them various text boxes, do whatever sort of arithmetic manipulations we want with the text here, which is fantastic. So getting the text, right, is calling get. I don't know what all this end stuff is. That's probably fine. And then it sets the label text to be something else. So the label is what we're setting the text of here. So this is a label that we're changing the text on. We have our print button and we have the text box we're working with. So lots of fun options. Unfortunately, we don't have tons of time to get into the interesting pieces of things. I know I promised you a little bit of time to work on the project. We didn't have Monday, so hopefully you don't mind me running most of class today, but I think we're pretty good. Just want to throw this out here. It's cool things we can work with, cool things you'll see. It's hard to memorize any of this stuff, so just go Google it, right, for examples, and we can find things and tweak them and figure out how to make them work. That's sort of what we would go from there. So, and if you want, add graphing for your final project. That'd be super cool. Totally optional. Just the big text output's perfectly fine. And I did have a couple of people ask about what the output might look like. So that's not even the right one. So just something like we might have some sort of list. Like this is my player's starting hand value, and then I might have this is stand wins, stand losses, stand draws, and then hit wins, hit losses, and hit draws, like as one line essentially. Now getting it to line up here might be a little trickier, but sure, this is my starting hand value of 4, and then how many wins did I have? I had like 12 wins because the dealer busts sometimes here. How many losses did I have? A whole bunch of losses here. How many times did I draw? Well, you're probably never going to draw at 4. Right? You shouldn't have any draws till you get to 17, 18, 19, 20, 21. So if you're seeing draws at values other than your hand value of, I'm sorry, let's be starting hand values. For standing, you shouldn't draw. When you hit, you should be able to get to a draw if you're within 11. Right? So you shouldn't have any stand draws until you get to 17 for a starting hand value. But your hit draws, you should start seeing starting at 6, because you can get an ace and go from 6 to 17, and it's possible to start drawing. Right? And then hit wins, right? So when I hit, maybe I won, 200 times, and I lost, a bunch of other times, and I drew. So again, should not draw. Right? Draws aren't possible at this point. And just keep on going, right? So 4, 5, go 6, 7, 8, 9. It's even better if we add in the dealer's starting hand value. I don't think I required that one, but let me double check. I should make sure of what we're doing here. Yeah, let me make sure it's in. Yeah, so this is each starting value. You get better results or more interesting data if you also look at the dealer's starting card, but not required at this point, right? We're still basic. So if you do want to track it, even better. If you're not tracking it, that's okay. Don't feel bad about it here. That sort of thing, okay? So just some basic table to spit all out to the screen, and we're good. Okay, thoughts, concerns? We feeling okay? So if you get stuck on anything, let me know. I can meet, usually after my kids are in bed, I can meet late at night, do a screen share, get you pointed in the right direction. So the goal is for you to not show up on Wednesday and say it's not done. Is that a fair goal? Right? More than anything, I love when everyone gets it done. And the presentation day is like, everyone is successful, everyone gets 100%. I'm like, this was a good day. I don't like failing people. So, and if you got stuck on something, let me know. So ideally before Wednesday morning, because that's a little late, right? So even Tuesday's pushing it. So hopefully the rest of this week we can get it knocked out if you're not done with it yet. and we can go from there. So sorry I wasn't able to meet you at lab, but if you do have questions, I can be available late at night usually. So, all right, and then I'll be hanging out in the CIS building for office hours after class today. I'll be here till about 3, and I gotta head home before traffic gets bad. Okay, it's been a lot of fun. Thanks for the semester. I am working on getting the stuff graded. I'm so sorry for all the delays. I'm terrible at this. It's not been the semester I wanted. I think most of the quizzes are in now. All the labs should be in, I think. So I just got to get to the projects and midterm here. So, but hopefully, I'm hoping, and tell me if I'm wrong, but having the rubric makes you feel a little bit better about knowing how you're going to score. If it's still awful, I apologize, and I'll be getting that in this week. So we'll know for sure before you take or present the final. So. All right, if you got anything else, let me know. If not, you take care, and I will see you Wednesday. Oh, I do remember one more note. I'll put in your Zybooks score on December 9th, but if you need another day or 2 or 3, that's okay. Like I'll take it through when you present the final. It's not ideal you're finishing that late, but like don't ruin your Friday trying to get it in by midnight. Okay, if you need a little extra time. And then 95% and higher, I'm just going to give you all the points because it's getting the last point or 2 here and there is not the most important thing, right? So I might actually go put in the scores now so you can see what they are, and then I'll go run them again probably when we do our final project presentations. Does that sound okay? All right, I'll do that. Thanks.